I want to look at one final thing regarding validation. Remember that name argument on the validate method that I said we could ignore for now? What's that used for? Well, where it applies is when you're validating named options. That's right, you can also easily validate your named options instances using iValidateOptions, providing different logic for each logically named instance. The solution already contains another iValidateOptions implementation. This one validates the external services configuration. As we saw earlier in this module, we have a single external services configuration options class, which is bound to two different configuration entries. Using named options, we've defined a logical named options instance for the Weather API configuration and another for the Products API. The name string is passed to the validate method when validation is triggered for a named options instance. This validation class provides validation logic tailored for each named instance. In this example, we switch on the name string. In the case of the Weather API, a helper method is called to validate the configuration. In the case of the Products API, the code defines a specific validation rule, checking that the URL is present and that the mins to cache value is not configured with a value of less than 1 minute. Each failure condition includes a string to provide the failure message. For the default case, when the name has not been matched, the code calls validateOptionsResult.skip, indicating that validation was skipped due to the option's name not being matched. The validate weather API config helper method is very similar, but it only validates that the URL is configured when weather forecasting is enabled. Of course, we must register this extra iValidateOptions instance with the dependency injection container. We'll copy the previous registration and amend it accordingly to register our second implementation of iValidateOptions. To support the validation of our external services configuration at startup, we need to amend how we register that configuration with the application builder. I'll comment out these existing lines, which add the named options configuration for the Weather API and Products API. We'll use the more specific add options registration here instead. Add options accepts a first argument when using named options. This first add options call will register the Weather API configuration. We bind it to the appropriate section of the configuration. And to ensure validation occurs at startup, we chain a call to validate on start. We'll copy and amend this code to perform the same registration for the named Products API configuration. If we update the app-settings.json file to intentionally fail to configure the URL for the Products API, we can check that our new validation logic takes effect. When I run the application, an exception is thrown at startup. Upon viewing the details and expanding the failure, indeed we see an error message indicating that the URL for the Product API is required but has not been configured. Options validation is a handy feature, but it requires a little extra work on the part of the developer. As we've seen in this demo, options validation can even be applied to named options. Before we move on, let's fix our configuration so that it will succeed during validation. In this demo, I want to briefly demonstrate a technique which achieves a common requirement I've seen people wanting to achieve. Many people find including a dependency on the generic options interfaces to be a little verbose. They prefer a cleaner, simpler abstraction around the configuration options. There's no specific need to do this, and in some cases, it may prevent using some of the options features. However, if you mainly depend on injecting iOptions of T, then you may only need the strongly typed configuration aspect of the options features. Let's open the content configuration class. We'll begin by extracting an interface using the Visual Studio tooling. Such an interface can be defined manually if you prefer. Content configuration is a simple class with a single property which we will include on the interface definition. Pressing F12, I can navigate to the new interface. By default, the check for profanity property is defined on the interface with both a getter and a setter. The intention with this interface is to define a consumer abstraction, so in fact we only really require a getter here. We can remove the auto-generated setter. We previously consumed this options class in the homepage configuration validation class. Now that we've defined an interface for consumption, we can change the first parameter to accept an iContent configuration. We must also remove the call to the value property needed when accessing an instance via iOptions. The final step is registering this interface as a service with the dependency injection container. In the program file, some configuration is registered inside an extension method called add_app_configuration. If I navigate to that method, we can add our forwarding service registration. We still need the registration for content configuration to ensure that it's bound from configuration. Below this, we'll define a new singleton registration with iContent configuration as the service type. We will handle the resolution of this interface by providing an anonymous function as an implementation factory. We'll effectively forward requests for this interface to return an instance of the content configuration class provided via the options pattern. Note that we're defining a singleton registration here, which is safe in this case because we don't plan to support options reloading. For reloading scenarios, you may want to register a scoped service forwarding via iOptions snapshot instead. The implementation factory delegate has access to the runtime service provider. We can call the getRequiredService method on the service provider, requesting the iOptions of content configuration instance. We then return its value property, the bound content configuration instance. To check if this works, I'll run the application. Perfect. Our dependencies were resolved and the homepage loads without any exceptions. This approach of forwarding options to interfaces is quite popular because it can help simplify unit testing of dependent classes. It can certainly be used to achieve that, although, as we'll see in the following clip, there are various ways to unit test types that depend on the options interfaces directly.